Okay, hey everybody. Here's a video showing you how to find the area of a sector, which is basically just a portion of the circle's area. So just to recap how to find the area of a full circle, of course, it's pi r squared. That shouldn't be anything new. And if you're given, let's say, the diameter is 16, we should be able to find the area of the full circle with no problem. So the area, of course, is pi r squared. If the diameter is 16, well, then r, of course, is half of that. And so our area is going to be approximately, let's just do it in the calculator in one shot here. 8 squared, of course, is 64, so 64 pi. So 201, let's say 0.1. 201.1, and that's going to be square feet. Okay, so again, just make sure you have the radius, pi r squared. You can use the pi button for ease, and then do whatever rounding they say to do. Notice the units is, of course, square units, since we're talking about area, and that's just a little recap for area of the circle. Now, if I want to find the area of a sector, which is just a portion of that circle, which you can see up here, it's a little hard to see in the video, but this is shaded here. This is the arc we're talking about, or excuse me, the sector we're talking about, cut by this arc or bound by this arc AB. Okay, so that's the arc, and it's the area in between. Okay, the area created by the central angle and the arc that it hits is the sector. So just think of it as like a piece of pizza, if you will. If we want to find that area, we have to know what portion of the circle represents the arc's angle, which of course is the central angle. So that's why this looks kind of familiar to when we did arc length, because you kind of had to have the same value for that. You needed the measure of the angle of the arc out of the full 360 for that part of the proportion. So the area of the sector out of the full area of the circle should be equal to the angle of the arc that contains it divided by the full 360. And again, the way I prefer to do it is I actually will have, the pi r squared on that side, the area, but it comes from this proportion. I like to have the area of the sector piece isolated already, since that's usually what I'm looking for. Okay, so again, this represents the portion of the circle you're working with out of the full area of the circle. That's the area of the full circle right here. So if this was 180 degrees, let's say, just to make it easy, 180 degrees out of 360, of course, is half. Take the full circle, divide it by 2, and you'll get the area of the sector, which is the semicircle in this case. What if it's not 180? What if it's not 90? What if it's not an easy sort of portion to use? What if it's like 106? Well, the good news is this formula will work no matter what that central angle is. So the sector is going to be equal to 106 out of the 360 of the full circle. Okay, so that's essentially your setup. It's always going to be the area of the sector is going to be the portion of the circle you've got, which is found by using the arc's angle, which of course is equal to the central angle, right? Out of a possible 360, and then times the full circle. So in this example, it's going to be 106 out of 360 times pi 9 squared. And if I let the calculator do all the heavy lifting, I'm going to get 106 out of 360 times pi times 81, and I get about 74.9, and that's going to be square feet. Okay, so that's the portion of the circle. If I did pi r squared just by itself, and I took 74.9 and divided it by that, I get the same fraction as 106 out of 360, give or take a couple of decimals. All right, for the next example, it's another one where you kind of have to work backwards. They're actually giving us the area of the sector. So I actually know what this part is. So it's going to be 6.4 equals 80 out of 360 times pi r squared. Now, just for the sake of trying it a little differently, let's the last one we actually substituted this for circumference when we had it. I could substitute that for A, for area of the circle, and just solve for it, since that's actually what they're asking for. But for the purpose of just trying something a little different, let's pretend it asked us for the radius, just for the practice of it. What if we only needed the radius instead of the full area of the circle? How would we do that? So the way I would do it is I would keep that all the same, but I would sort of focus my eyes on just this part. So I reposition my parentheses so I can leave the r squared alone. I'm not going to be able to do anything with that right away. I want to figure out what this part is, right? Because if I had an equation that looked like this, 10 equals 2x, I don't think anybody would hesitate as to what to do. But when it looks like this, it's hard for people to kind of figure that out. So believe it or not, this is like the 10 This is like the 2. This is sort of like the x. Okay, I know it's squared, but it's the same idea. I want to solve for that. So I need this part. So I'm going to go ahead and do that. I'll just do that part separate in the calculator. I could kind of combine it all, but I want to show all my steps for this one. And I get about 0.6981. So 6.4 is about 0.6981 r squared. Okay, so I went a little further with the rounding because I'm not done with the problem yet. I kind of want to save my final rounding for the end. So now if I come up here, I can divide both sides by that 0.6981. 0.6981. So 6.4 divided by 0.6981, I get about 9.1677, and that's approximately what r squared would be, right? Because this part's going to cancel. So basically what I just did was I divided both sides by 2, right? And I get x equals 5. The problem is it's actually x squared because it's r squared. So if you want to get x when you have x squared, or you want to get r when you have r squared, hopefully you remembered, you do need to take the square root. So r is going to be approximately, and now I just need to let the calculator do that part, 9.1677. Get about 3. Let's go, it doesn't say it around. And actually, I just made that problem up anyway. So I'm just going to call it 3.03. I don't know. I feel like I want to put a little extra accuracy in there. So I gave it to the nearest hundredth instead of tenth. Now for the fun of it, since I know the radius, if I do pi r squared, which is 3.03 squared, I should get the area of the circle. Area of this full circle is going to be about 28.84. Now we could have gotten that right on the first shot here if I just taken care of the fraction and divided it over, right? And this is, by the way, square feet. Watch this. This is what we did in the other video. If I basically just replace that with a, 6.4 divided by 83/60ths. 6.4 divided by, well, we can simplify that. This is 8/36, right? Which is 2/9. So divided by 2/9. And check it out, 28.8. Okay, so you could have done it in one shot here, but for the practice, I wanted to show you how to find R. But if you see those little, depending on what they ask for, you might be able to see little shortcuts like that and go ahead and use it. Okay, so there's some examples using area of a circle to help you get area of a sector, or kind of working backwards. And of course, if you have any questions, feel free to ask, and I will see you guys later.